Hi, welcome back from Dan's bathroom. Again. I don't know about you, but I'm starting to feel pretty comfortable in there. So let's think about this question that Dan posed at the beginning of the clip about men and women and their different use of hair products. He started with the assumption, right, that maybe many people have, that women use a larger number of hair products than men do. And so to test his assumption, he went into his bathroom, he pulled out all the hair products, divided them by gender, and then had a somewhat surprising conclusion that maybe, at least in this case, the man in this situation uses more than the woman. And so we kicked it back to us and said, let's analyze this. So we have some data that we're going to look at, and we'll test the hypothesis, we'll run through the calculation, and then we'll come to a conclusion at the end. So the first thing we'll do is write some hypotheses, right? Just like always. So start with your null hypothesis, write your research hypothesis. It can be either one-tailed or two-tailed, whatever you think the relationship is. Maybe you do agree that women use more hair products, or maybe you think that men use more, whatever. Write whichever type of hypothesis you like. After you're done, hit play again, come back, we'll compare what you have with what I have, and then we'll move on to do our statistical analysis. Okay, did you finish? Great. So let's look at my hypotheses, the ones that I wrote, and see how they compare with what you wrote. So every time we write a null hypothesis, it's going to say about the same thing. It's going to say there's no significant relationship between variables, or there's no effect of one variable on another. So in this case, we're going to say that there is not a significant difference in the number of hair products used by gender. That's indicating that one is not causing the other, is not affecting the other. Now, our research hypothesis in this case, what Dan started with anyways, was women use a significantly higher number of hair products than men do. So I've written a one-tailed hypothesis. If you wrote it like this, there is a significant difference in hair product usage by gender, then you're not predicting men or women are higher. You're just saying, let's look at this. That's a two-tailed hypothesis, right? This is going to be important at the end when we come to a conclusion. But I've written a one-tailed hypothesis, so that's kind of the assumption we're going to make throughout this problem. Okay, so now that we know what we're testing, let's go ahead and look at the data and see where to start. So we just asked some men and some women, how many hair products do you use on a regular basis? So for women, it ranges from 1 to 5, and then there's an 8 in there. And then for men, it ranges from 1 to 5. So we'll just see what the mean is for each of these groups. This is something you already know how to do. We're not going to test you on it again. So let's just see the mean for women and men. It's 3.5 for women, 2.9 for men. Okay, so there is a difference, right? So we could just stop here and say, oh, okay, women use more than men. But what we're doing in this class is trying to figure out if the differences that we see between groups or populations or whatever is significant enough to draw a conclusion that says, yes, this is a serious issue. Maybe not so much with hair products, but yes, we've definitely found a relationship here that means something. So for instance, if we found that women had 3.5 on average hair products in their bathrooms and men had 3.4, that's about the same, right? That's there, you can already tell that's not going to be a meaningful difference. And if it was 3.5 hair products for women and 1 for men, clearly we're onto something here. But this difference of 3.5 minus 2.9, it's just about a half of a hair product if you want to think about it that way. Is that significant? That's what we're about to find out. And so we need to figure out which test to use. We're using the t-test, obviously, since we're in the t-test module, but why do we know that that's the right one? Well, our dependent variable is measured on the ratio scale. You can count, it's from 0 to as high as we can get. There's a definite difference between 0 and 1, 1 and 2. And then our independent variable is nominal, men and women, right? We could do this by race, we could do this by region of the country. Those are all nominal variables. So we're comparing a dependent variable, its ratio level, by groups, just by categories. And in that case, when you have 2 groups, we want to use a t-test. If you have more than 2 groups, then we're going to use ANOVA, which is the next topic. But for today, we're just going to focus on this gender difference, which is between 2 groups. Okay, so let's look at the formula to see what we're getting ourselves into. Hey, that doesn't look so bad, right? It's just the difference between means. We already have the means. We're just going to pop those in, divided by this sigma. Okay, what's the sigma? Let's just see what that is. Oh, so here's the sigma formula. It's a little bit more complicated than the first one, but don't panic. It's not as hard as it might look at first. Let's look at it. There are 2 square root signs since they're sitting together, we're just going to multiply them, right? That's not difficult. Now let's look under the first square root. We have a fraction. On the top of the fraction, we have n1 times s1 squared. That just means the number of people in the first group, let's call that women, and the standard deviation squared for the first group. So we just calculate the standard deviation for the first group for women, and then we square it and multiply it by the n. That's basic. That's pretty easy. On the other side of the plus sign, we have the same thing. The n of the second group, the n of the number of men, and then the standard deviation of men, and then we square that. And then we divide that product, or that sum that we get, just by the number of men, the number of women, subtract 2. This is basically our degrees of freedom. It's a little hint for later. And then under the second square root sign, we're just manipulating the n's again. So it looks big. It's a little bit time consuming to calculate, but it's really very easy. So once we get this whole sigma mess figured out, then the t formula is going to be really easy. Just subtract find the difference between the means, divide by the sigma, and we have it. All right, so the one thing, we do have our means. We have both means figured out. We can get our n's really fast by just counting the number of data points in the male group and the female group. So what we need now is the standard deviation for each group. You know how to do this. You've been practicing this, and so we're going to give you another chance to practice. So we're going to ask you to pause. We're going to put the data up so you can see the data points for women and for men, calculate the standard deviation, and then once you're done, come back. We'll make sure your answers are correct just so that we're all on the same page, and then we'll move through the sigma calculation and then the t-test calculation. Okay, did you get your standard deviations, one for women and one for men? Okay, let's see how you did. Let's start with women. I'm going to show you my calculation table and see how it compares to yours. So as you'll see here, I got 1.80 for the standard deviation for women. So if you got that, great. If not, let's just think really quickly about how I got this. So I started with each data point, subtracted the mean to get the deviation, squared the deviation, and sum those deviations. That's how I got 39, that number in the yellow box. And then the standard deviation is simply that number, 39, divided by the number of women. That gave me 1.80. So if you didn't get that, pause for a second, go back and think through what you've done. But let's move on then, assuming we got it, and see the standard deviation for men. That's our second group. All right, and here is the calculation table for the standard deviation for men. I got 1.51. Did you get that same thing? If not, just look back through what I did here and see where you got off track. If you didn't get 22.9, then your problem was up in the calculation table. If you did get 22.9 for the sum of squared deviations, then just look back through that calculation to see maybe if you just plugged something in wrong, maybe the wrong n, something like that. Okay, remember, to calculate the t formula, we needed the two means, the n's of both groups, and standard deviation. We have all of that now, right? So we're going to go ahead. And remember, to start this t formula, we have to start with a sigma, right? To calculate the t formula, we have to start with a sigma, and then once we have that sigma number figured out, we'll plug it into the t formula. Okay, so what do we need for the sigma formula? We need n, the n's for both groups, we need the means for both groups, or the standard deviations for both groups, and that's what we just figured out. So let's just plug all the numbers in and see how it works out. So we'll start with the first group. The n is 12, and the standard deviation is 1.8. And then we add that to the n of the second group, which is 10, and we multiply that times 1.51 squared. Divide by the n's minus 2, and then plug the n's into the second part. All right, so we have 12 times 1.8 squared. I just want to do a quick reminder. You have to square the number first and then multiply it by 12. That's just how this goes. And then do the same thing on the other side of the addition sign, and then add those two together. Okay, so let's do the math out and see what our answer comes out to. All right, so you plug everything in, you simplify everything, and then our sigma value is 0.74. So take a minute if you need to, pause if you want to, see if you can follow what happened here. We plug the numbers in, and then the next two lines are just doing the math. Make sure you understand exactly how that went, because you're going to do this on your own, and you want to make sure that you understand the steps. Okay, but we did it. We have the sigma value. Now we can go back, plug that into the t formula, and we're almost done. Okay, so remember, the t formula has just the difference of means on the top divided by the sigma. And that should make sense to you. The question is there a significant difference between groups? And we're comparing them on the mean of the average number of hair products that they have in their bathroom. So it should make sense that we're comparing means. And on the bottom, we're just what we're doing there is just adjusting for the number of people in the group and how diverse the groups are. Okay, so we have everything we need. We're going to go ahead and plug everything in and get the t-value. So the mean of the first group is 3.5, the mean of the second group is 2.9. And on the bottom of this equation, we're just going to plug in the 0.74. Just like this. So we're dividing 0.6 by 0.74. All right, calculate that out, and the answer is 0.811. Great, we did it. We calculated the t. It took a few steps, but we got here, and it wasn't terrible, right? But okay, what does 0.811 mean? What does that tell us? What does that tell us about our hypotheses? Do women actually have significantly more hair products than men? We don't know yet. There's one more step. It's an easy one, though. It's one that you're familiar with. We're going to take this calculated t-value and see if it's either higher or lower than the critical t-value. And that critical t-value is going to come from the t-table. Just like we did with chi-square. We looked up a critical chi-square value. We're going to look up a critical t-value. And we need 3 things this time. When we go to the t-table, we're going to need 3 things in order to use it. It's going to look pretty similar to what we did with chi-square, just one more step. So we're going to need the significance level. The t-test is going to ask us which significance level do you want to be at. And you remember, for this class, we're always going to use 0.05. So we're saying we're okay with about a 5% chance of incorrectly rejecting the null hypothesis. All right, the second thing we're going to need for the t-table is the degrees of freedom. In general, the degrees of freedom is the number of cases in the data set minus 1, or some variation of that. In this case, the variation is the number in the first group added to the number in the second group minus 2, or N1 minus 1 plus N2 minus 1, right? So either way you want to think about it, we're taking the number of people in the entire data set and subtracting 2. And then the third thing we're going to need is to remember back to when we wrote our hypotheses. Did we write a one-tailed hypothesis or a two-tailed hypothesis? Now, you may have written a two-tailed hypothesis, but we're just going to work out the rest of this problem for a one-tailed hypothesis. But when we look at the t-table, if you'd like to go ahead and look in the two-tailed column, that's fine. Okay, so we have what we need. We need 0.05 significance level. We need to know that we have a one-tailed test, and we have a degree of freedom of 20. That's 12 plus 10. 22 minus 2. So we have a degrees of freedom of 20. All right, so let's look at the t-table and find our critical t-value. So we want to go in first, the top row is telling us to look for a one-tailed hypothesis. That's what we have. That first column of numbers is the 0.05 significance level. That's the column we want to be in. And then we'll just go down, down, down until we get to the degrees of freedom of 20. Okay, you see that, right? That's 1.725. That's our critical t-value for this problem. Okay, so we're almost done. Let's compare our critical t-value to our calculated t-value, and we can make a conclusion. So our calculated t-value was 0.811, and that is lower than 1.721. And if you remember, when the calculated t-value is lower than the critical t-value, you haven't found a significant difference. You have to say, oh, the null hypothesis was right. We have to fail to reject the null hypothesis and say there is no significant difference between men and women on the number of hair products they use, right? That was the null hypothesis, so there is not a significant difference. And so Dan's assumption at the beginning of the video was wrong. But this is the conclusion that he came to by the end, right? He was thinking, oh, maybe there's not such a difference. And he ultimately was right. So this process that we've just been through, I'm hoping is starting to feel a little bit more comfortable to you, because we're going to keep doing it throughout the class, both calculating t's and walking through this hypothesis testing series. So work out some homework problems until you feel comfortable about it, because you're definitely going to see this t formula again.